Hello, everybody, and welcome to the Microsoft Data and AI South Florida user group. Today, we have a great presentation coming up with Dustin Vannoy. He will be talking about Microsoft Azure Databricks and processing, streamline processing, real-time data there. So, without further ado, let's get started here with Dustin. Hello, Dustin. How are you?
Hey, I'm doing great. How about you?
Oh, well, thank you. And welcome to the Microsoft Data and AI user group.
Yeah, thanks for having me.
Pleasure. Thanks for you being here with us, supporting the group, supporting the community, and sharing some great knowledge. Where are you located at?
I'm in San Diego, California.
All right. And how has it been the start of the year for you?
Pretty good so far. So yeah, things are rolling along, and it's looking better than 2020 so far.
That's very positive. Happy to hear that. So, tell us a bit about the presentation. I know you'll be talking more detailed, but give us an overall view here, real quick.
Yeah, so we'll be talking about how we do streaming data processing. So how do we deal with data that's streaming all the time rather than batch oriented and the nightly jobs, which is kind of the more traditional approach that I did for many years. We'll be doing this with Azure Databricks, which means we're using Apache Spark, and then there's some other components of the Azure ecosystem that we need to talk about for it all to kind of come together as to how the data flows from some source application all the way through to our data lake in this case is what I'll be demonstrating.
All right, so we'll be taking here pretty much the data processing to the next level, trying to make or near real time or real time processing. So getting those streams such as Twitter and or other applications, right? Can be business applications, uh, web data, IoT data. I believe they would all fall under the purview of it.
Yep, for sure. And IoT, there's kind of some special things that you might use in Azure for IoT, but the capabilities are pretty similar. And so as we talk about Azure Event Hubs, that'll give you a good overview. If you end up working with IoT hubs in Azure, it's a pretty similar technology, just a different use case.
Excellent. So it sounds like the skills we are going to learn here today will provide information for whether it's someone who is just moving from the regular batching process, trying to bring to a more leverage streaming to make it more real time, as well as those individuals that are out there doing IoT and or other web applications or even potentially API calls that integrates through it as well.
Yep, exactly. And so I'm a data engineer, so it'll be a very data engineer perspective on dealing with streaming data, not so much on the final analytics visualization piece, even though it's a super interesting topic. We'll kind of do some basic visualization in Databricks and talk about kind of how you could go further from there.
All right, so sounds like we'll be able to get an experience here for, as you said, the data engineering aspect. And for those of you who don't know, the check out the link below on the description section where you're gonna see Dustin's information. You have his blog, and he was talking exactly about it. And if
Mhm.
you all stay through the end, at the end, we may be able to, bring in a couple questions to Dustin here if he's available and everything, talking about data engineering as well. And at the end of it, I'm also going to be announcing the presenter for the next session. And you have an opportunity to ask questions at any time. Just make sure you subscribe, click the bell to be reminded, and by being a subscriber and logging in, you'll be able to use the chat where you can enter your questions here for Dustin. All right, as you watch the presentation right now, and or at the end as we talk about more about data engineering, so you have an opportunity to interact and engage with the presentation, as well as addressing any questions you may have there about data engineering, folks. All right then. Without further ado here, Dustin, let me, let you come in here. And it's all you now.
All right, thank you. Let me get the screen shared, and then we'll cover some some of the topics through some slides and discussion. We'll take a break to look at Databricks, talk a little bit more about Spark, and then come back to a more complete demo of Spark structured streaming within Databricks. So the first thing I want to do is just give a little more info about myself. I'm a data engineer, as I said. I'm doing consulting now, so I'm an independent consultant. I'm a partner with Alliance. If you happen to come across that really good consulting firm that I work with quite a bit, you can contact me through LinkedIn or Twitter, or just send me an email if you prefer. I usually share out on those social media platforms when I have a new blog post or video posted. The types of things I talk about, the types of things I do every day are modern data systems, looking a lot at data lakes, analytics in the cloud, streaming data like we'll talk about today. I primarily am speaking about Azure since that's my main focus these days, but I spent years doing AWS. And so you'll see me talk about that. We can definitely talk about the differences of technologies on AWS if there's time in the Q&A session at the end. I love to work with Spark and Kafka and Python, and we'll see all those things in play, at least the Kafka APIs, and we'll talk more about that as we go today. The other thing is that I'm one of the leaders of the Data Engineering San Diego meetup group, and you're always welcome to join us. We meet the first Thursday of each month, and a lot of times, most of it is just group discussion about the topics that people suggest and vote on. And so we'd love to have you join the conversation with us. So the agenda, I'm going to present to you why streaming is important. We'll keep this short, but why it's important and why it's a little different than San Diego meetup group. And you're always welcome. Then we're going to talk about Apache Spark structured streaming and the Databricks technologies that we'll use within Azure to do this type of Spark processing. And then I want to kind of zoom out a little bit and show you a pretty simple but important reference architecture of where Databricks fits in, how the data makes it to our Databricks jobs, and kind of where we would store the data for data lake querying and additional processing. So to kick us off, to try and get you on the same page as me and be excited about streaming. So it's important to shift to streaming because that's where the industry's going. It doesn't mean that batch is dead. It doesn't mean any, buzzword things to try and get you to click on an article link. But if you haven't started doing any sort of stream processing, you're probably headed that way if you're a data engineer or if you're in this data analytics field. And so the way I think about this, kind of the shift I've had is that at some point I stopped trying to convince everyone that we can just do this in batch. Let's not make it too complicated, and realize, life's not a batch. Life is a stream. We are constantly changing what we're doing when we work with something, when we use something like Netflix, when we go and shop on Amazon or some other e-commerce site. Each time we make a click, each time we do something different, we're expecting things to react to that. We don't want the recommendations of what they thought we wanted to see yesterday. We want it to adjust and to adapt to what we're doing now. At the same time, even more internal business decisions can be changed a lot quicker than they used to. And so having one big nightly load drive all our business decisions for the day, it's just not meeting the use cases all the time. And so to kind of dig into that, so we data engineers, maybe you're not in this boat with me, but those of us that have been telling our business organizations for years, you don't need streaming, you don't need real time, you can just do this in batch because it's a lot easier for me to build it that way. That's starting to change. For quite a few use cases, the customers that are using our products, the business leaders that are making decisions, they know that this stuff's possible. They know that our competitors are doing it, and we can't just keep making excuses. We need to really dive in and do this well. Maybe I'm preaching to the choir, but one of the things that always comes up when I have this conversation, especially with technologists about doing streaming data processing is, is streaming harder than batch? Is streaming easier than batch? And so like most things, there's some trade-offs. So one of the things I want to call out is that processing one giant data set every night, like we do with kind of traditional ETL for data warehouses, it's not actually easy. It's not always the simplest way to do it. We just have gotten used to it. We have practices to deal with it, and we've got our on-call schedules and PagerDuty and whatever we're using to make sure that it gets done before everyone wakes up. But no longer, many companies are no longer have the liberties of all their customers going to sleep at night. We have global companies, we have things happening 24/7, and processing data as that comes in can actually make the logic quite a bit cleaner sometimes. It doesn't mean that everything's easier, but we can actually simplify our logic if each record that comes in or each small batch of records that comes in throughout the day, we do the cleaning, we do the augmentation we need to make it more useful as the data is coming in. We still might have some, scheduled processing to aggregate data together. Trying to do joins on streaming data is challenging, don't get me wrong. But as we either have a need to go to streaming or choose to start doing our ingestion in a streaming fashion in order to prepare for the future, we'll find that there's actually some things that are cleaner about it and a little bit simpler to understand when we do it this way. So the way that I'm going to talk to you about doing streaming is using Apache Spark structured streaming. And so we don't really, we don't use this as an acronym. It's not really one that we walk around shortening, so sorry for the long name, but when we hear someone talk about using Spark for streaming, they might be talking about the more legacy Spark streaming, and there's nothing wrong with using that. But often, in the last few years, if someone's talking about using Spark for streaming, they're talking about structured streaming. Basically what that, yes. No worries. Okay. Keep on going here. So with structured streaming, the way I like to think about it is one of the lead developers, TD, said this several years ago now, is that it's a fast, fault-tolerant, exactly once stateful stream processing without having to reason about streaming. And probably the most important thing in my mind is that we're trying not to think about the fact that we're streaming too much as we write the code, as we write the logic, but it's going to enable us to do stream processing. So let's kind of go to why Spark in general, because a lot of the times I'm going to Spark for my streaming solutions because we're also using Apache Spark for all kinds of data processing. So Spark is a framework that we use because as big data became part of our everyday lives, as we moved to the cloud more and more, our mindset changed, and we want tools that they may not be as specialized, but they definitely need to scale as our business grows. We might acquire a company, we might suddenly go viral and take off, and we need to scale up quickly. Spark is one of these tools that can scale with the data just by adding more nodes to a cluster. So it's horizontally scaling. We'll just make sure we're all on the same page about that in a moment. This really gained popularity. Apache Spark gained popularity because it came out of the Hadoop ecosystem. So companies that were doing big data processing with Hadoop could now get away from MapReduce API, get away from a lot of disk reads and writes, and use memory for a lot more processing, and the Spark API, which was a lot simpler for many of us. So Apache Spark is for big data processing, and it is a fast, general purpose way of doing data processing. So if you, what's up?
Just 1 second, sorry about that. Hi everybody, please press F5 on your screen to refresh so you can see the live chat on the right side. And when you come in, if it shows up, just say hi there. Thank you. Thank you, Dustin. Sorry for interruption.
No worries. So we're talking about what is Apache Spark. So it's general purpose data processing that can work with big data. It allows us to write simple code and do parallel compute on a cluster. So we're doing distributed computing with relatively simple API once you get the hang of it, of course. So we can do this in quite a few languages. Scala and Python have been the go-to languages for writing Spark code. I typically am in one of those two languages when writing Spark code, but Java and C# and R all have support. Java's definitely been around a lot longer than these others, but all of them have been making progress and getting used more heavily. Within Spark, there's a lot of different modules. It's less important to cover those at the beginning, but know that we'll be working with the Spark SQL module Today, even when we're doing streaming, we're Spark SQL streaming, which is different than just pulling in Spark streaming. And I'll kind of point to the import statement when we use that later. And then the execution engine. So it's not just an API and a framework. It actually runs on a Spark cluster, which needs an engine. And so there's Spark standalone, which is the one that comes, built into Apache Spark. But then if you're running on top of a Hadoop, you'd be using Yarn as your resource manager. And so quite a few different managed Spark environments are using Yarn. Some managed Spark environments, such as Databricks, have Spark standalone or some kind of customized Spark standalone cluster. You can run it just on your laptop. And there's Kubernetes and Mesos and things that are also used beyond. Probably the longest running ones have been the standalone and the Yarn clusters. So I talked about horizontal scaling. We're going to get this really simple for just 30 seconds here. So hang with me if this seems too simple for you. But what are we talking about with horizontal scaling? We're talking about if I need to move from one home to another, I might hire, a specialized, really good mover. But if there's only one mover, there's certain things they probably can't do. I could probably get by for cheaper just by buying some pizzas and getting 10 of my friends to come and help me move everything. Maybe they bang some stuff up. Maybe it's not as smooth. There's definitely some orchestration and coordination, but the idea is that if we have more and more work to do, we can just get more and more people, or obviously we're talking more and more servers in the mix. And so what that looks like, kind of as a super high level architecture of Spark, is that we have this controller node that's part of our cluster. And we're going to run our applications off of we're going to run driver applications that run off the controller. And then that's going to assign a lot of work to the workers is typically what we call those. And so I might have 2 workers, I might have 4, I might have hundreds. We're basically saying with our simple API calls, go ahead and spread this work out, run it in parallel. And as we get more and more data, we can often just add more workers to get better performance or to be able to handle a larger load. So as we're doing Apache Spark in Azure, the primary way we're going to do this if we're doing streaming is Azure Databricks. The Azure Databricks, if you're not familiar yet, is it's a unified analytics platform. So Databricks is a company created by some of the founders of Spark, the original creators of Spark. Azure Databricks is one offering that is like a first-class service within Azure, and it's taking all of the capabilities that Databricks has put around Spark and making them available to us just by spinning up a Databricks resource in Azure. As a data engineer, the main benefit I want from this is a managed Apache Spark cluster. Really, it's a managed Apache Spark workspace, because when I start to work with Spark, most organizations want notebooks on top of it that allow this like interactive, shareable way of querying the data and working with the data. I'm going to get performance optimizations on top of that just because of how Databricks make sure that their open source, but then modified version of the code base is all going to work well within the cluster for you. And I'm going to get auto scale and auto terminate. What this basically means is that I can start with a small cluster and give some parameters for Databricks to decide to scale it up and down as the day goes on, as more jobs get submitted to it. I can also say if no one's doing anything on the cluster for a period of time, usually it's 100, it's about 2 hours, something like that. Go ahead and turn this cluster off because clearly we're not using it. Let's save some money. The downside to auto terminate, by the way, is it takes about 5 minutes to spin those clusters back up if you don't do some additional management by having some VMs in a pool and some really advanced cool things we can do. Typically, though, you're looking at 5 minutes to spin the cluster back up. But you save a lot of money when it's a development cluster. If your development team's all going to sleep at night and that cluster's just sitting there, you'll save quite a bit of money by keeping auto terminate on. And if you're doing this in your own environment like I do, keep auto terminate on and maybe even bump it down to like 20 or 30 minutes. So the interfaces we use for Databricks, these are the main ones I would use. I'll say it that way. There's probably a few more you could find. So we're going to use notebooks quite a bit, and we're going to use Databricks notebooks. So if you're used to Jupyter notebooks or Zeppelin or some of these other notebook capabilities, even Azure Data Studio notebooks, it's a similar type of notebook, and you'll get to see that a bit in my demos. We could use our IDEs, whether it's VS Code or PyCharm, because there's a Databricks Connect client that we can install, and we could write Spark code and run a Python job or whatever right on our IDE and have it reach out to the cluster and do all the Spark stuff over on our cluster. There's a REST API. A lot of times I use this for scheduling jobs or spinning up new clusters. And then Azure Data Factory can be used to, with Spark, a lot of times I'd use it more as an orchestration component. So run an Azure Databricks notebook, maybe get a little bit of output from that run, and then kick off the next dependency down the line. And so Azure Data Factory can be used for orchestration and kicking off some of these Databricks jobs or notebooks. So with that, let's take a little breather from slides here and take a look at what the Databricks workspace looks like, just so that everyone on the group here can be in the loop on this. So this is our Databricks workspace. By the way, if you have questions at this point about the basics of why the heck I'm talking about Spark, why I'm talking about Databricks, get those questions in the chat. We'll try and take those pretty soon. But the Databricks workspace allows me to create multiple clusters. And so that's the main thing you want to know, is that I could have a cluster for my marketing data science team and a cluster for my finance team and a cluster for my data engineering team, or maybe multiple depending on the job. And so there's a UI which you can create clusters in. I won't go deep on that. I think I have a YouTube video still around about it, but main thing to know is that you pick a version, and they have very recent versions of Spark with the latest version of Scala that it works with available for you. So we're not really behind the times just because we're using a managed Spark environment. Auto scaling is the click of a button. See how it says 2 to 8 max workers? We can click that on and off. Auto terminate that I mentioned is right here, and I can bump that down to whatever I want. And then as I get to initializing things when the cluster spins up, setting Spark configurations, all of that's down here too in the advanced section, including, by the way, passing through, depending on your level, passing through your credentials to the storage underneath to make sure you have permissions coming from the user running the job all the way down. So we can have multiple clusters. I have one running, which is good. That means our demo won't have a 5-minute delay when I get into the notebooks in a bit. The home page you saw has, kind of a quick overview of what's possible here, and we'll kind of leave it at that. What's possible is kind of where we'll pause on this workspace overview. So I can see my recent notebooks. That's very handy, of course, to find things I need to use. You have ML flow, and you can manage ML models here, which is one of the other capabilities of Unified Analytics Platform. I don't spend any time talking about that. I focus on the more data engineering, Spark heavy sides of it. One of the things I do find myself using, though, is the data pane, which is the tables I create within the Spark database. And so as we're working with Spark, we can register tables here, and that will keep the data around and easy to query for any other user that jumps on the cluster. In this case, these are actually shared across the whole workspace, which is a pretty cool thing, that we can share that metadata across the workspace if we like. Probably the one other thing I'll show to make sure it's clear that we can do this is that we can create jobs that have schedules to them that can either be running a notebook or running a library that we've written and packaged up and loaded up here for our Databricks workspace to access. That can spin up a one-off cluster when it runs, or it can use a always-on cluster that I have. And of course, there's a few other configurations around alerting and things if things don't go smoothly. So that's the Databricks workspace. So it's just kind of a portal for using Apache Spark, and it comes with add-on capabilities, of course, including making security and permissions quite a bit easier to manage than if you're doing this all yourself. All right, do we have any questions we want to throw out there yet? Okay. A lot more to share, so it's not surprising, but feel free to start typing them in whenever you get them. So the next step is to go from, I kind of talked a little bit about why Spark, showed you Databricks. Let's talk a little more about Spark structured streaming. And I'll show you a little bit of code samples here too before we do that more reference architecture view of the world. So if you're used to Spark but not Spark structured streaming, this might be useful for you to know, is that the traditional approach was just called Spark streaming, and you use dstreams as your data object. Here we'll be using Spark SQL API with streaming mode, which means we're using data frames. I'll try and explain what a data frame is as we're loading it up with data here. And then the way you know you're using structured streaming, if you're finding examples online, is that you're going to import Spark SQL streaming. So I already talked about this first quote about why Spark structured streaming exists, why it's a good way to go about streaming. another quote from TD to throw out there is that the simplest way to perform streaming analytics is not having to reason about streaming at all. And basically, the way he talks about thinking about it as a developer is that you've got this constantly appended to table in the background. So each micro batch of data, each second or 2 seconds or whatever that small trigger is of data that you're collecting, is being processed and appended to this streaming table that's back there. And so we'll read that data in with a command that hopefully doesn't look too complicated even if you're brand new to Spark. But we've got the df on the left side is just a variable. This is PySpark code, Python code to work with Spark. df is a variable. It stands for DataFrame. So that's our data class. It's basically going to end up pulling in the data and looking like a table with a bunch of methods on it. So it's got columns and rows to it. Spark is our Spark session. We'll see that just comes already available in the notebooks. It's not too hard to create if you're not using Spark notebooks. So we'll do our Spark session.read stream. And that's pretty much how we kick off a streaming read. We just need to tell it a format. Kafka is the API that I'll be using here in Azure. And then each format will have its own set of options to configure it, such as what are the servers I'm pulling from, any credentials that I need to access it. And then .load is going to say, I finished configuring my read. This is my my initial definition of a streaming data frame here. Typically, you're doing quite a bit of stuff between that read and this write, but let's focus on the start and the end, and I'll show you a few more code snippets to make sure we're getting a feel for Apache Spark streaming. So on the write stream, on the data frame, we can call write stream to write this data back out. One way that I'll commonly do this in data pipelines is I'll actually have some steps to the job that are reading the data in from the source application has sent it to Apache Kafka or to Azure Event Hubs. I do some reading and processing, and then I write it back out to Apache Kafka or Azure Event Hubs for multiple consumers to deal with it. But there's quite a few different formats you could choose to write the data out to. We can talk about those in the Q&A if you have more questions at the end. One of the things you'll always need is a checkpoint location. And this is important to make sure that it sticks around so that if the job stops for a bit, you can restart it from the place you left off, that you know what the message you read last and be able to kick it off from there. And then the start command at the end is how you really kick off this streaming query. So we have the read, we have the write. You could take these two commands, fill in the config and have a little Spark job that just replicates data basically from one Kafka topic to another is what this would do. So obviously we're probably going to do a little bit more besides that. And so we, with grouping and aggregation, there's this concept of a window I want you to be aware of. So we have our data in a data frame. This is before we do the write. We can group it by some kind of set of keys. In this case, I'm just specifying that there's a column called vendor ID. And then I'm specifying a window of 10 minutes on one of my dates. This is basically my event date, my pickup date, if we're working with taxi data like I'll show you today. And so it's basically going to average that trip distance across a 10-minute span of time. And there's a few different window options you can choose from. We can talk a little bit about that if there's questions, but that's pretty easy to find in the documentation, the different window options. But know that if you're going to do aggregation and grouping, you're basically going to specify what window of time you care about so that it knows how to do that calculation. Somewhat tied to that aggregation or the types of joins you do is this output mode. When I'm writing the data out, I need to specify, or I can specify what trigger interval I want. And so it's going to default to 1 second, at least last time I checked the docs on that one. So it's going to run every 1 second. It's going to do a micro batch, do some processing, and write that data out. If the data's too much or there's too many transformations that it takes more than a second to process a batch, it'll just kind of adjust and trigger a little bit less quickly than you ask it to. Often you'll be working with the append output mode, which is saying every record I get in this little micro batch I'm processing is new. Let's just do the processing and add it on to the end and the destination, just append it to the destination. But if you're doing things like aggregation and grouping by, like vendor ID would be an example. We kind of just want to keep this thing up to date all the time and keep displaying it in some kind of downstream visualization tool, then complete mode could be a way to do that. And so it would give you just the latest state of the table after the calculations and groupings that you've done. There's also an update mode. I find that there's times that's useful where it's basically saying, is anything new or is anything changed based on the key I've given it? Often that's not quite the right fit for my use cases, so I kind of left it out of my slides there, but that's something to look into if you think that fits your use case. Okay, so that's the kind of quick intro to Spark structured streaming. And now let's kind of zoom out to where this Databricks and Spark fits into our simple data pipeline architecture within Azure. So in the simplified view, I won't get too complicated anyway, but we'll start super simple. I have my source data. If I'm doing streaming, it's probably going to be some type of application or API that users are interacting with, or our websites using under the, as the back end, that is writing data out to some kind of layer that then Azure Databricks reads from. So we could, try and read straight from a file system. I'll show you a little bit of that, but usually there's a little bit of a middle layer that we have to add, but basically Databricks is doing the heavy processing and it's writing out to my data lake. In Azure, you'd be using Azure Data Lake Storage. That'd be Azure Data Lake Storage Gen 2, by the way, if you're actually setting it up. So it's a distributed file system that we can use in Azure, and it integrates really well with Azure Databricks. A couple other things we can mention about that in a moment, but as we zoom out just a little bit more from our super simplified approach, we kind of have two modes a lot of times that data will get to Databricks. So one is that we have Databricks go get that data itself, and I would usually orchestrate that with Azure Data Factory to kick off a notebook or a job. And Databricks is reaching out to a database, and they're doing batch polls at that point. So that's not the streaming mode. When we get to streaming mode, something like Azure Event Hubs is there as the kind of the broker, as the middle layer where data is constantly being streamed to Azure Event Hubs. Databricks is constantly pulling data off of Event Hubs and doing the processing and landing in the data lake. We may have some additional processing where we read that data back out of the data lake, process it some more, or join it to the next set of streaming data, and then write it back. So this could be a little bit of a cycle here. We have multiple phases to this processing, but these are the key components that we're probably going to end up with for most streaming use cases that are using Apache Spark structured streaming in Azure. Okay, so a few things about data lake storage, a few things about event hubs, and then we'll move on to a demo here. So feel free to ask any questions on the last section as we go, and we'll get to those soon. Data Lake Storage Gen 2. If you're familiar with Azure, but not Data Lake Storage Gen 2, it's really not a huge change to set it up. It's part of the Azure storage. You just set up an Azure storage account, and there's a checkbox that's hierarchical namespace, and that's going to switch you into this Data Lake Storage Gen 2. So basically, instead of having a bunch of blobs with these paths that tell you where the files are, there's actual folders and directories, and you can do permissioning at the folder level. If you move or delete folders, it happens at the directory level, at the folder level, instead of every file in the storage being completely separate, just with a logical path like it is when you use Azure Blob Storage. So this is optimized for cloud analytics. The cost is going to be pretty similar to using Azure in a traditional Azure storage, standard Azure storage. And it's built to work with the Hadoop APIs. At this point, you could pretty much use, from what I've seen, you can pretty much use either set of APIs, the blob storage APIs or the Data Lake Storage Gen 2 APIs with either type of storage account, and they're highly compatible at this point. So Data Lake Storage is where we kind of store a lot of the data if we're building out a data lake. Of course, there's SQL Server and other places we could be streaming data to. Upstream, and remember on the before we get to Azure Databricks, we got to get that streaming data from somewhere. And we use Azure Event Hubs or Apache Kafka. I'll talk about the differences in a moment. We use Azure Event Hubs as a reliable place for our applications and our services to stream events into. So they'll just be sending events to Azure Event Hubs, and they don't really care too much about who's consuming from it. There's not too much, we can kind of decouple all of our consumers from those that are producing the data. That's where Azure Event Hubs fits in well. So Event Hubs is a scalable message broker. It keeps up with the producer, everything the producer is sending, persists that data for a period of time. You can go from 1 to 7 days persistence so that you have that data around temporarily, but long enough that consumers can replay messages if they get lost, if they fail. You have some amount of persistence there, which is a little different than how we usually would set up like a message queue like RabbitMQ. Now, Why would we use Event Hubs over Apache Kafka? Let me just real quick call out for those that aren't familiar with Apache Kafka. Apache Kafka is often talked about as a distributed log, but it's a big message broker too. You could use it that way. And Apache Kafka is the open source platform that came out of LinkedIn and is super popular among data engineers like me for doing streaming, for doing this this capability that I'm telling you Azure Event Hubs can do. The reason I would typically go with Azure Event Hubs if it can do everything I need for my use case and I'm in Azure is that it's a PaaS offering. It's platform as a service. I can spin it up, set it to auto scale, and not have to manage servers, not have to do nearly as much overhead as setting up Apache Kafka myself. Certainly there's other ways to get managed Apache Kafka, but within Azure, Event Hubs is a really good drop-in that has good capabilities. Plus, with Azure Event Hubs, if I have people doing .NET development, they can use the Event Hubs API, which the Event Hubs SDK, which is probably going to work a little more naturally for them. Whereas those of us working with Scala, working with Apache Spark, can use the Kafka APIs, which is probably the example I'm going to find online. The code I've written in the past has always been using Apache Kafka. So it's an easy transition to use the Apache Kafka APIs with Azure Event Hubs. So whether we're using Azure Event Hubs or Apache Kafka, this is the sort of the visualization of what I'm explaining about decoupling the producer from the consumer. So we'll have topics or event hubs such as trip data or vendor data that are source applications or producing data to. Those make it into Azure Event Hubs, and we could have multiple consumers for each topic, for each data stream into Azure Event Hubs. You know, one example is that we'll probably have our Databricks job that's running. We'll have our real-time reporting, whatever that looks like, and some kind of user dashboard that could show up in the application and let a user see that, hey, you know, you just took this trip and here's the vendor and maybe kind of a summary of the cost, whatever it happens to be. And there's, of course, some sort of schema and contract that the producer is using when it sends to Azure Event Hubs, but it's not a direct, you know, coupling with those that are consuming it. The consumers just need to stay up to date with whatever is being produced, much like if you're using APIs to get data moved from one service to another. A few key concepts, key names about Azure Event Hubs. I've pulled out some of my Event Hub slides just so I don't bore you too much on this side, so we can come back and answer questions if you have them. But when you go to set up Azure Event Hubs, you're first going to create a resource that's an Azure Event Hubs namespace. So a namespace is a container that holds multiple event hubs. Up to 10 event hubs, I believe, is the current limit. And so each event hub is like a topic or a stream of data. I kind of moved into this world from the database world. And so I think of a topic often as how I would define a table, how I'd split up my table data. And so trip data probably has its own schema and would go to its own table, and I'm going to make that its own topic. Vendor data, user data is probably all its separate topic. Probably all the data that comes in has a very similar schema, and I'm not trying to, as a consumer, switch between different data schemas depending on the message. That gets a bit messy. So we try to keep the schema the same within a topic, within an Azure Event Hub. Usually, that's the way I architect these, at least. There's some key concepts that you'll want to look into if you're deciding on sizing. So there's partitions within the topics, and you have partition keys that get used to basically figure out how to load balance, how to spread out the messages to be consumable in parallel. There's a little bit of difference in implementation. You could find some things that Apache Kafka does that Azure Event Hubs doesn't do, but I found for the use cases I've really tried to use it for, it's worked well, and I have been able to go with Azure Event Hubs if I'm on the Azure platform. And then one key item to look at, and there's some actual documentation that tells you the exact throughput that it supports, but throughput units is how you decide scalability, and you can set some level of auto scale. That's at the namespace. So if you have really big event hubs, you may want to get those in separate namespaces so you can scale them differently. But assuming that you can get enough throughput units to handle a load, you can put up to 10 event hubs all in the same namespace and manage them that way. And then this is just a heads up in case you're like me and want to go try this at home. If you want to use the Kafka API, then you can't be on the basics more for test and development anyway. But if you want to use the Kafka APIs, you need to get up to the standard level when you're setting up your event hubs. Okay, I'm going to go into demo and we'll spend some time there. We'll take some questions on there. And then I'll have just a few more tips about working with a data lake when you're doing streaming towards the end. Do we have any questions in the meantime as I make the swap over? All right, sounds good. So you should see my demo page. Let me know if that perfect. Okay. So I've been finding the best way to show this demo is to start at the end and then come back and show the code. So hang with me, trust me, I have a plan. We'll see if it works. So I'm gonna kick off all of the stream processing. It's really like that's about eight cells, but only some of them have code in them. Kick off the stream processing, and then I want to show you how this very simple visualization within my Databricks notebook will grow as the data flows in. The other thing you can never forget to do is make sure you have data flowing. So let me kick that off too. If people are interested, I haven't done a lot with the output, but I have a Twitter demo that's easy to go with, but it's hard to control the input for that. So I'm going to run New York City taxi data. I'm going to loop through and stream 1 or 2 messages a second so I can kind of control that the data is coming in, that we don't have big gaps in the data. And there's a bit of transformations that I've come across in my days to do on this data so we can see Spark in action and not just a simple read-write. Okay, so we're starting at the end here. What I'm doing is this data is being written to my data lake as Delta format, and I'm reading it back in and visualizing it for you. So I have one borough of Manhattan. We should see that change unless it's my zooming that's messing it up. There we go. We see data flowing in. Looks like every 5 seconds or so, it's updating my screen here. If you're watching these numbers are climbing. So I do have data streaming in, and within the notebook itself, I can get some amount of visualizations going here. The data visualization capabilities in Databricks is just getting better and better. There's some stuff in public preview that I'm not showing that has some more capabilities as well beyond what's built into the generally available stuff. All right, but I want to teach you about the Spark side, not just show you a bar chart moving because that could be faked too easily. So we're dealing with New York City taxi data that is available as a public data set in Databricks. If you experiment over in the Azure Synapse side, by the way, this same data set, I think it's a different year, but the same data set's available. So you can kind of take a lot of this code and port it to Azure Synapse Spark as well. The first thing we need to do is just import some things, import some libraries. I'm using PySpark, so PySpark, SQL, etc. Set some paths and define a schema that we will convert our JSON Event Hub messages to. So as data comes in, all of it's going to fit this schema here. So it takes a little getting used to the struct type for creating a Spark schema. Once you get the hang of it, though, it's really not too bad. And this is kind of my preferred syntax for doing this. I have a lookup table I use. I commented that out. We don't need to keep running that. That's just a simple batch read, column rename, and write. Let's get to the streaming stuff. You may notice that I find it's nice to just start fresh each time. So I have a version that I kind of append. If you see that down below, I'm just changing the version each time I run this so we can start with a fresh batch of data, both in the data lake and on the Event Hubs topic I'm using. The configuration, if you're going to use Azure Event Hubs for Kafka like I'm using, is you need some kind of connection string. This is probably true even if you're using the Event Hubs APIs. You need a connection string. It's going to look something like this. You can find this in the Event Hubs namespace or on a specific event hub by browsing the portal, but you don't really want to hard code this into your notebook, especially if it's anything close to production or real data. You don't want to hard code this into your code base, and you don't want it to end up in GitHub. So what we do is we use Databricks secrets. And so dbutils is just Databricks utilities. They have these things called secret scopes. In Azure, we can take an Azure Key Vault, which is Azure's answer for managing keys and secrets and certificates. We can connect that Azure Key Vault to Databricks through a secret scope. I should have a video on YouTube of how to do that if you're trying to get that done. But that's the best way to do this if you're if you're doing a real world example. So ultimately what I'm doing is saying, pull a key out of my, or pull a secret value out of my demo secret scope. And then I throw that password that I got into this crazy string here. So this Sassel string is the way you may not find this first thing in the docs if you're trying to do Event Hubs for Kafka. Maybe it's there now, but it took me a little searching through blog posts to find this the first time. So in Azure Databricks, Kafka shaded is going to be where those Kafka libraries we need are. They should be there on every Databricks cluster that's out there. So you can just take this code and modify it with your own password and connection string. And then this is a way to get the security credentials passed through in the configuration. Group ID, for those that are familiar with Apache Kafka or Event Hubs, that's like our consumer group ID. So I like to change this if I'm running a different application or doing a fresh run. Basically, when I'm running in parallel, if I have multiple instances, such as on Spark, I have multiple workers hitting this data, it's going to use the group ID to make sure that they aren't reading the same message. And so it's going to say, well, I got 4 instances, but they all have the same group ID. Let's make sure we're taking turns as to which messages we put for each service or each Spark worker that's reading the data. I'll save you the talk on the consumer config. You can probably tell where you need to do a replacement if you're taking this code. But with that Sassel string I build, the group ID, the topic, and putting your own namespace info in there, you've got a config for consuming from Event Hubs for Kafka. And so now it's starting to look a little bit like the code I showed you on the slide. So we're a read stream with the format of Kafka, passing in those configs. Now there's some special stuff that happens when we're dealing with JSON messages that are streaming, and this is true of whether we're using Azure Event Hubs or we're using Apache Kafka. We're going to get this record, and in that record there's a value, there's a key, there's a timestamp, and a few other metadata items. So what I'm doing is I have a data frame. Input data frame knows about the table and the column that I'm going to get. In this case, it's just a set of rows. Each row is a Kafka record. From that Kafka record right in here, I'm selecting the column called value, which is some bytes that has all of the info in the message. I cast that as string, so I can then work with it as a string of JSON data. And then I have this from JSON function, which is going to say, I've got a string of JSON data, convert this to a JSON object that I can then reference easier. So I do from JSON, I give it a schema, so that Spark schema we set up above matches what this JSON data is, and I can pass that into my from JSON function. And then finally, I give it a name. I'm just going to call this column JSON. Pretty easy and simple there. So we've built up this new data frame that's the JSON data frame. Now I'm going to create a transform data frame. In that transform data frame, I take my JSON data frame. I'm going to select star from my JSON object. So if you're doing a select statement in SQL, select star, it's the same idea right here. I've unpacked this JSON object into a column per item in the JSON object. And then now I just do some transformations column by column. So first, what I do is I do some replacing of dashes with underscores and make a year-month string that I can use for partitioning down the line. I convert a couple of strings that are really dates into actual date objects within Spark. And then I calculate a tip percentage just by a simple tip amount divided by total amount. This next piece is where I take that lookup table. I kind of skipped over the commented code for you. I take that lookup table and I do a join. So I'm taking streaming data and I'm joining it to static data. Some data I just read in once. I'm not expecting my taxi zones to change at all while this job's running, and I can do this join. So I take my transform data frame, that's what we just set up here on line 39, doing a join to the zone data frame. This is my on clause here, so saying I have a pickup location ID on one side, a location ID on the other side. I want to do a left join, drop the location ID because that's extra, rename a few columns to get them a little more clear, and that's all I'm doing in that transform step. This is where you have quite a few options of where you would go next. After we've done this transformation at like a micro batch level, each micro batch goes to that transformation. Each set of, in my case, it's like 1 to 5 records each time. It's not a big set of data that gets processed through that each batch. Now I can do the write like I showed you before. So I take my latest data frame, I do a write stream. Delta format means it's going to go to files, and these files are going to be managed with the Delta Lake APIs. And so Delta Lake is open source, but it's also originally developed primarily by Databricks developers. There's a proprietary version that Databricks offers up. It's got a few special things that just aren't available in the open source. Ultimately, though, what it does is let me write a whole bunch of small files and make sure that as I read and as I write, that we're not colliding and getting, dirty reads and having other problems that you might see if you're working with normal file systems. And it's also going to give me some capabilities to compact these into a more efficient, better optimized set of files later, which is why this is kind of one of the only ways I would really expect to write streaming data to a data lake in a pretty quick fashion like this. Otherwise, I'd probably be looking for more like 5-minute or 10-minute batches. All right, on with the show though. So we've got our append mode selected. That's the one that I said we'll probably use most of the time we're doing things. I have a checkpoint like I told you need to do. I've added a partition by so that as this goes on and on for months, that it will save each set of data in its own month folder. And then I call start. And in this case, since I'm saving to a file, I pass in my file path to my start command. And now we're back to where we started, where I've written this all to Delta Lake. I've just got a super simple read it back in from Delta Lake and display it. Display is a Databricks command, so it lets me, when I'm working in Databricks notebooks, easily collect that data and do some things with it. And if you're paying attention to numbers earlier, we're in the hundreds, I think, when I first showed this. We're getting up there. So it's just collecting more and more data from the time I started up this job. The other thing I'll show you, and this visual won't be, I think will help get the point across about Windows as I'm talking here. So the other thing I'll show you is that I can read data from that path and do a group by with the window. This is almost slightly different from the example I had in the PowerPoint, but I'm windowing every 20 seconds. So I'm saying give me a sum and an average for every 20-second window, and go ahead and sort those descending so that I can grab just the latest 20 windows of data. And then with this line here on line 14, I do a few processing things just to make it easier to read. And then if you watch closely here at this cross tab, you'll see that it'll basically, the number one element in the list will change, and we'll just see that each window comes in, shows up, and the numbers will be for that specific window of time. So this is, not exactly the output you care about typically, but this is what's going on under the covers when we're doing windowing. I'm trying to make sure it is changing on us. It's hard for me to talk and double check the accuracy of this all at the same time. It should be swapping some stuff out. I see things moving, but I don't see the window start changing the way I expected. So I might be a little out of sync here. Notice though, one thing that's interesting to know about really windowing or watermarking or some of these core concepts in Spark streaming is that the window time is not, current wall clock time. The window time is really based on the data I processed. So the max time in the data I processed is what's driving the window. So the max, where is it? The max pickup date time is what's driving that window, which is an important concept to get. Even if you don't get it right away, you'll need to get that along the way as you work with streaming. With that, I don't think we need to go through these other methods necessarily unless there's questions related to it. Do we have, while I'm in demo mode, I think we're doing okay on time. Do we have any questions yet? If not, I can finish up the prepared slides and then we'll come back to any questions. All right, you got that? So make sure you press F5, refresh your browser. Okay. So if you have a question, make sure you press F5 to refresh your browser and put your question in the chat there. Yeah, so we have a great question, which I actually have a slide for, is if there's a need to clean up the files that we're doing with Delta. Let me show you. We'll answer it this way since I had a few slides around this because it is important to know. When you're working with Delta Lake, remember I talked about this special way of working with files. When you're working with Delta Lake, it does some things for us. It gives us ACID compliance in a data lake, which is amazing. It's not what this talk's about, but that's kind of what allows us to do streaming. It also gives us some capabilities to compact small files. The problem that we're being asked about is, hey, do we really want to leave all these small files around? And I think the person asking the question probably knows, no, we don't. All these small files would lead to too much metadata to manage as we're trying to, map our schemas to actual files in Azure Data Lake storage. It leads to more file open and close operations. We're probably going to end up with a Spark task per file. And so a lot of really small tasks rather than being able to break it up into much larger tasks that Spark can deal with more effectively. Compression isn't going to give us as much savings, probably no savings at all, really, because these files are so small. And especially if you switch over to MapReduce or some other tools, you'll really see some issues there. And this part maybe we'll come back to. So I don't think I have my Delta. Let's see, if I don't get this right, we'll come back to it. But basically, here, I'll do this. I will find you an example that shows how to optimize that. Any other questions while I'm working on that? Right. So if you're using Databricks, the question is on Databricks Community Edition. Could you use that to do this demo? Kind of. So there'd be ways. I'm not sure about the secret scope that I showed. You cannot use Databricks Connect with the Community Edition. So despite what Stack Overflow says, linking to my blog post on that, you can't do that with Community Edition. But you can do, I think, pretty much everything I'm doing here with Community Edition. Except it's going to be running over in AWS, and you'll have to probably manage the credentials for Data Lake storage differently. I didn't really say it mounted so that I can call it pretty easily. I don't know if I have them shared out yet, but you can definitely follow up on Twitter or LinkedIn with the question. So the code to authenticate and use Azure Data Lake storage within Azure Databricks, it may take a little bit of time to get it right, but it's done. It's something that's out there. You can do it. And I'm pretty sure you can do that from Community Edition as long as you open up the right ports and everything. I could always try that, though, if you approach it and have too much trouble. Probably would be easier if you're not really doing anything in Azure, if you're just using Community Edition, is to go and use some other storage layer and just kind of go and tweak these to get the data from elsewhere. You could probably... Yeah, the big difference is I'm streaming data right now. So I've actually downloaded some of the data that's available in the New York City taxi data set, and I'm sending it back up to Event Hubs. So this demo is a little bit harder to recreate than some of my others because of the fact that it's streaming. But definitely follow up on Twitter or LinkedIn with more questions on that. And if you're going along that path, I could help with pointing to the right scripts and all of that. All right, let me address the Delta question. I think I saw it, but then I started talking too much. All right, so I'm not sure if this path is still valid. We can try it. That's an old path. We will try to optimize the thing that I just did. Yellow Delta path, okay. Let me grab the path and let's see if we can optimize this thing that we just wrote all our data to. I'm on 1.5, I think. So basically, there's a couple ways to do it. You'll usually see a SQL statement, which might actually be easier for whatever reason. I tend to leave the SQL form of Spark and go into the actual methods and everything here. If I take, so I'm not really a live coder typically, so I don't have the right setup for not making a bunch of mistakes in front of you, but eventually, there we go. It'll recognize my typing correctly. And we're going to see if I've imported everything I need just in this one cell to make this happen. But this is one way to do it. Here we go. And then the other way to do it with an additional Z order in there, which is a way to kind of get some index type performance improvements off of it. So the Spark SQL way to do it is with this optimize command. And then this is pretty close to how you would do it with Delta tables, I'm pretty sure. Perhaps I got that wrong, though. I'd have to double check on that. So if you don't find the exact answer, let me know. But yeah, using the Delta optimize, usually syntax kind of like this here at the bottom of my screen is the way you would go. You would want to run that pretty regularly to compact those files for you. Any other questions at this point? Yeah, so definitely if you have questions, get them in. I don't have a whole lot more to share there. I'll kind of start to summarize what I'm hoping you got out of that, and then we'll see what questions there are. If you want to see, trying to remember, you mentioned Twitter data, but I don't think it's really going to show too much different if we look at Twitter data right now. I don't have a whole lot else going on with it at the moment. So let me just kind of yeah, sorry. Yeah. Thank you. All right. Let me give some final thoughts. Get your questions in if you have them. You can see me, right? All good? You can see my final thoughts slide. Yeah, that's fine. Is my mic muted? Okay. All right, good. Teams is telling me it's muted, but okay, great. All right, so I've got some references here. Maybe I'll leave those up for a second as I'm talking. So my thoughts on this is, obviously, if you want to go into Apache Kafka or Azure Event Hubs, there's a lot more to learn. And so I've got some reference here, and I can always throw those in some notes, I'm sure. If you want to see more demos on using Apache Spark in general, I've got some of those. A link or two in my slide deck is for videos that talk more about Spark structured streaming. As you get to, if you're trying to actually do streaming joins and deletes and things like that, it gets way more complicated than we've talked about. And no matter what streaming framework you use, it's going to get complicated. So as you build into more realistic scenarios, it gets, more and more complicated. But often what we'll end up doing that I think is well talked about, though sometimes people pretend we don't do it, is we have these streaming jobs. We do a bunch of stream processing, but we also have some amount of like batch job cleanup that maybe we run it every 15 minutes. Maybe it's really frequently run batches, but we do clean up downstream to make sure that as data needs deleted, as updates happen. It's often hard to get that perfect in something like Azure Event Hubs, to get that data perfectly updated there, because it's not a database. It's this event log. It's this, stream of messages that don't change once they make it there. And so it gets tricky as you go, but a lot of times what we end up doing is balancing a good, well-coded streaming data set with some amount of batch data to clean it up when deletes happen and when major changes happen that are hard to handle in a streaming fashion. So Apache Spark is really powerful and capable to do all sorts of batch and streaming workloads. If you're going to be using Apache Spark for batch, it's pretty easy to switch to streaming from a code perspective, because you're just switching out a little bit of the commands here and there. You can still keep a lot of the same transformations once you've loaded your streaming data frame instead of your normal data frame. But ultimately, monitoring and keeping it going in production is a little bit of a different ballgame than batch jobs that run once a day or once every hour. And that's where a lot of the hard work of streaming comes in. And so there's a lot to it. It does get really advanced. I'm not trying to say that you can switch to streaming today and your production jobs are ready to go. But from a coding perspective, you can do it. It's becoming more and more important to be able to. And so trying to find those use cases where you can at least ingest the data in a streaming fashion is where I'd point data engineers. If you're not actually needing to get it to a dashboard real time yet, at least start ingesting that data in a streaming fashion where it seems appropriate so that you are ready for the next steps when, someone wakes up and says, we need this to update on the website, every few seconds or at least every minute. We can't wait till your next batch job runs. Great, great. So the last minute things on comparing Apache Kafka to Azure Event Hubs is Apache Kafka is so there's a company called Confluent that if you're around Apache Kafka, you've certainly heard of Confluent. They're like the Databricks for Apache Kafka. If Databricks does to Spark what Confluent is for Apache Kafka, I would say. And they have a lot of really good tools for doing streaming, for managing Kafka. They have their own cloud. I'm pretty sure last I checked that you can use their cloud with your Azure environment. And so there's a lot of things on the Kafka side that are actually Confluent created and kind of more from the Confluent team, and not all, some of it's open source, some of it I think you would need to license. And so there's a lot of really cool stuff there. And so one of the reasons I like using the Kafka APIs is so that if for any reason we do see limitations in Event Hubs, pricing would be the thing. I guess I didn't mention that in the presentation. Pricing is the thing I'd be the most concerned about when making the decision. So take into account, having someone manage Kafka for you and what that looks like. But as far as like actual cost per transaction that's going to flow through the system, you'll want to price that out if you're looking to do this, long term for real. But assuming that the pricing meets your budget, you're going to save a lot of overhead with management and things like that if you're within the Azure stack and go with Event Hubs rather than another Kafka offering. Those are the things that come to mind for me. So I found that it works well using Event Hubs. But there's a lot of tools that work with Kafka that you can use with Event Hubs. I just don't know if things like exactly once all the way through. I would not expect that to be the same experience using the Confluent suite of tools with Azure Event Hubs. So there's like transparent disk encryption on the storage layer when you're using Azure storage. And so the transparent disk encryption, which is one good level of encryption, is going to be there on the data lake. And my understanding is that Event Hubs does have transparent encryption as well. Certainly something your security team will want to review, but we've looked at that and seen that as something. I forget if we had to turn it on or if it's always on. A practice I've seen to be, I guess, more secure, or especially if there's things like HIPAA in play for the data, is to encrypt certain fields within the message. So something like a social security number, if that has to travel through Event Hubs, you might additionally encrypt that. And it's going to add some overhead to your job to have to encrypt at the field level. None of us really want to have to do that. But that's a way to deal with some of the security requirements for your company or compliance requirements. I've also seen done, I haven't done this as much, but I've seen the whole message being encrypted in Event Hubs. And I've seen encrypting the whole file on, like with PGP encryption or something, on Azure Blob Storage to add that additional layer of encryption to it. So I feel like for a lot of use cases that aren't HIPAA, PCI type things, the transparent disk encryption is going to get you pretty far, and you'll need to take really good security practices around networking and all of the things you should be considering in the cloud. But then if you're dealing with SSNs, credit cards, things that are highly sensitive, chances are your security team will want you to put some extra layers of encryption on there. And it's a little bit homegrown, but it's doable, and many companies are doing things like that. Any other questions? Yeah. I'll add while we wait to see if there's more questions. If you go check out my website, dustinvannoy.com, I don't have a specific resources page, but I do have some blog posts around my journey in data engineering and skills that a data engineer would want to have. And I'm saying those not to plug myself, but to say that I have some additional references. I think I have a Pluralsight channel with some resources I thought were pretty good. Some additional links on there for learning Apache Spark, maybe a few for learning kind of other data engineering concepts. And I'm a real person that you can reach out to on Twitter and LinkedIn, and I will try to answer your questions, especially if it's something that I think, others will find interesting. If it's finding more links or a really specific question that we think others have run into, I'll try and answer those for you. So don't hesitate to reach out. Yep, on Meetup, if you look for data engineering San Diego, it should pop up for you. And if you find me on Twitter, you will definitely, or LinkedIn, you'll definitely see each time we have a group. So I'm not as committed to posting it, but I do get it out there at least once before the meeting. So you can find it that way too. Yeah, we usually do about a 30-minute presentation and then group discussion. So it's kind of a combination. It sort of depends on who volunteers to speak. So the last one we did was just discussions, and we had some really interesting ones. But we've had people talk about getting started in your career in data engineering. We've had I've done a little bit on this type of topic of loading data lakes. We've had some good Airflow conversations, and it's not just Azure. We talk about all sorts of data engineering topics. Whether that's good or bad is up to you, but we're have a collection of people that use Google Cloud and AWS and other things. So we get to kind of compare and contrast and criticize the different technologies that we all find ourselves working with across companies and projects. Yeah, really common questions are like, hey, has anyone actually used Snowflake in production, and what was the experience? Or has anyone done this new feature that AWS just announced? Has anyone actually tried it to tell us if it's hype or if it's legit? So it's pretty interesting to hear people's experiences and perspectives. Best compliment I've got all day. Not even my kids say that about me.
All right. So again, thank you very much. Really appreciate the making the time, the opportunity to be here with the Microsoft Data AI user group. And folks, remember, check out Dustin's user group as well. I will be placing the link down in the description. Sorry about that. I'm just looking here what will be here for the next presentation. As I said, we will be watching, we'll be having here Learn Azure SQL Database through demos, and there will be with all right. So the next presentation we'll have Learn Azure SQL Database through demos, and you all probably know the presenter. It will be Anna Hoffman from Microsoft. I look forward to see you all there, and everybody have a good night, and look forward to see everyone in our next presentation. Remember, connect with us, check out the description for the Microsoft Data and AI South Florida user group, as well as the San Diego Data Engineering user group. All right, folks, you all have a good night. Thank you very much, and bye-bye.